so what does this first one mean? Yep. It's less than. Okay, what about the one below it? It's greater than. Okay, what about the one below that? Yep, so that one's going to be is less than or equal to. And then what about the one below that? Yep, it's greater than or equal to. And then what about the last one? Yep, is equal to. Perfect. Yep, so when you have that line added underneath, that means it's like the kind of the combo of the greater than, less than, with an equal to, okay? All right, so your objective for today, so this is all going to be solving equations and inequalities. We're going to start very, very, very basic today, and then it's going to speed up really fast, okay? So objective is students will be able to solve one-step equations and inequalities. And we kind of put equations and inequalities together whenever we teach this because they're basically the same thing. I think in the book it splits them up into two separate sections, so just kind of be aware of that, okay? So just the very, very basics of solving an equation. Your goal, like what you're trying to do, is you're trying to isolate the variable. So meaning you're trying to get the variable by itself, okay? And then there's that rule, what you do to one side, you have to do the other, because you're trying to keep that balance happening. And then the way that we isolate variables, I'm going to explain it two different ways. So the typical way that we talk about it is we do inverse operations. So you do the opposite. So if something has addition, what would you do? Subtraction. If it has multiplication, what would you do? Division, and so on. Yes. So another way that I want you guys to kind of think about this, because later this becomes relevant, is we're trying to take one side of the equation, and we're trying to create either an x plus 0, an x minus 0, or just a 1x. Okay? Hi. Can you come to like the last half? Would that be okay?
Yeah.
Yeah, okay, cool. Awesome. Thank you so much.
Thank you.
All right, so because what do all these equal? What's x plus 0, x minus 0, and 1x all equal? What do they all simplify to? Just x, right? So x is going to be by itself. And then there's also going to be part of this that you'll have to graph your solutions. And when we talk about graphing, we're talking about a number line. So let's go through how you would graph each of these. So if you just have an equal sign, x equals 1, that means the only possible answer is 1. So you're just going to have a dot at 1. If you have no solution, then there's going to be nothing on your graph. So you would just literally leave that graph blank, okay? Identity or infinitely many solutions. So what both of those mean is that you could literally plug in any number for x and it's going to work, okay? So that every single answer is a solution. So the way that you represent that on a graph is you just do a line going with arrows going basically from negative infinity to positive infinity, showing that all those numbers on the number line forever and ever and ever, every single thing will work, okay? All right, so now when we get over to the inequalities, we have not equal to versus equal to. So when I say x is greater than 1, that means that x has to be bigger than 1. So can it be 1? No, it has to be bigger than 1. It can't be 1. So the way that we represent that, so bigger than 1 is going to be this side of 1 for our arrow. But the way that we handle that actually at the 1 is instead of putting a normal dot, which means it starts there, we take our dot and we basically hollow it out. So we make it an open circle, showing that it can't equal right there, but it's everything above it, okay? And same thing for x is less than 1. So we'll do an open dot at 1, showing it can't actually equal 1, but it's going to be everything less than that. Yes, you have a question?
Yeah.
Uh-huh.
So if there was a negative, does that mean that it would go from
Yep, so that's just that the actual number itself, you would just like shift the placement of where the dot is, yeah.
So would it have to say -1 or -1?
It was a -1, yeah. So then the dot would shift over to where the -1 is. Yep. And then, so this one, x is greater than or equal to 1 now. So it's going to be the same as this top one, but now since it can equal 1, we're going to fill in the dots. So it's going to be closed. It is. So color in the dot, so it could be 1 or anything greater than. And then same thing here, it can be 1 or anything less than. Make sense? And that, like, if you logically just think about it, if we're talking about equal to or not equal to makes sense to color it in, not equal to makes sense to leave it open, okay? So just kind of think about it logically. And then, like I kind of mentioned, we combine these two sections because you solve them the same way versus splitting them up. But there is one difference between equations and inequalities when you're solving that you have to pay close attention to. So only difference, right down here, and I would really highlight this. So when you're solving an inequality, you flip the sign if you multiply or divide by a negative number. The reason why is because when you multiply or divide by a negative, you're basically turning everything to be its opposite, right? So the sign is not going to work whenever all of a sudden you switch over to opposites. So for example, if I have x plus 5 is bigger than 3. Okay. So can someone give me, actually, never mind, can't do it with addition. Forget that, because then I'm not going to be able to show you the difference. Okay, so we'll do a multiply one. So if I do -2 times x has to be bigger than 5. No, let's do 6. Okay? So -2 times x has to be bigger than 6. So give me a number for x that would work. Then when I multiply by -2, it's going to give me something that's bigger than 6. Any number, any number. Yep. -7? Okay, so that's going to be 14, which is bigger than 6, right? So we all agree that -7 works in that, right? Yes? Okay, so now if I divide both sides by that -2 and I don't flip the sign, I would get x is greater than -3, right? So now let's plug in -7. Is -7 bigger than -3? No, right? So this doesn't work anymore if you keep the same sign. So that's why anytime you multiply or divide by a negative for your process, you have to also flip the sign over so that all the solutions still work the way they're supposed to, okay? Just so you know. You don't need to know that, but just in case, so you can kind of think about it. Okay, so let's go to our first example. So remember that our goal is to get the variable by itself on whatever side it's on, and we're trying to basically get an x plus 0, an x minus 0, or a 1x, okay? So here, so I have x plus 13. I need that to be x plus 0. So what do I need to put on that side to make that make 0? Yep, so minus 13, because 13 and -13 make 0, right? So x equals, what's 19 and -13? And I would use a calculator for this, guys. I honestly wouldn't even use your brain power. This is about the process. You guys are being taught a process. Do not get these wrong because you accidentally subtract wrong. I don't, just put a calculator on a desk. Don't even think about it. Let the calculator do all the math work, okay? Yeah. Yeah, so x equals 6.
When it stops asking multiple choice, do you still make sure you're right?
So the multiple choice you don't really need to. It's the short answer section that you need to. Yeah, the multiple choice you're fine if you don't. Honestly, I would just to be safe, just show it for everything, and then you won't have an issue. All right, so on a graph, since it's just equal to 6, that's the only option for your answer. It's just made a dot on 6, and that's it. No arrow. 6 is the only thing that works.
So first you have to figure out what x is, and then you do it on the
No.
calculator?
So here I would do the 19 minus 13 on the calculator.
19 minus 13. And then you get the answer for x.
Yeah. Yep.
Oh, you just...
So yeah, I'm just saying, like, just don't, you don't have to do the math in your head. Let the calculator do all the math. Yeah. Okay, on this other one. So on this side, we have a b minus 3. I need that to be a b minus 0. So what am I going to add to this side to make that go to 0? So positive 3, because negative 3 plus 3 is 0. So then in the calculator, do negative 7 plus 3. Don't even think about it what it is. Just let the calculator do it. What's that?
Negative 4.
Negative 4, yep. Yep, so then you're going to put a dot at negative 4. Show some. You don't have to be like as crazy detail as this, but just show me something. Yeah. Even if it's like just what you're doing to both sides and you don't actually write it on both sides, I don't care. Just show something. All right, and then you guys try these ones. Okay, we done? Ready or not? Yep. All right, let's go over this. So, on the left side here, we have a plus 2. How am I going to make that into 0? Yep, a negative 2. Bless you. So you get y equals negative 5. Okay, and then on this one, we have a negative 8. How am I going to make it 0? Negative 8 and what makes 0? Positive 8, right? So m equals negative 6. All right, we good there? Any questions? Okay, now we're going to do the same thing but with inequalities, okay? For addition and subtraction, nothing changes. Nothing changes at all. So, for the first one,
On A on top of it, I got one.
did you do negative 3 and negative 2? That's not 1, so then you just
No, I did 2 plus 93.
But it's not 2, it's negative 2.
Okay,
Does that make sense?
I get it.
Yeah, so since you're having to subtract 2, that counts as negative 2. Yeah. So you have to do negative 2 and negative 3. All right, for this next one, so I have on, with the x, I have a negative 15. How do I make that 0? Positive 15, yeah. So x is going to be greater than 3. Okay, so now we have to remember on the graph, if it's only greater than 3, which direction is the arrow going to point? So which side of the number line have the bigger numbers than 3? The right side, right? So x is greater than 3, so all like 4, 5, 6, all the numbers bigger than 3. And then, can it equal 3 or can it not? Nope, it can't. So am I going to use an open or closed dot? Open, yep. An open dot at 3, showing it can't be equal to 3, and then to the right. And then on this one, we have an x positive 6 on this side, so what do we do to make it 0? Yep, minus 6. Okay, and then let's talk for a second about this. So I don't want you guys to get in the habit of looking at these and being like, okay, so that points to the right, so my arrow points to the right. Because that's only true if your x starts the problem, okay? If it doesn't, like this one, then that's going to be backwards. So I would prefer, and if you guys rewrote those ones and put the x first each time. So the way that you're going to do that is you're going to look at your problem. Is that pointing, like stabbing, is it pointing the x or the 4? It's pointing the x, right? Do you guys see that? That's pointing towards the x? Yes?
Yeah.
So when you rewrite it, you want to make sure that it is still pointing towards the x to make sure that it's the same thing and that you got it right, okay? If you want to rewrite it with the x coming first. You just want to make sure that symbol is still pointing at the same one that it was before, okay? So now, it's x is less than or equal to 4. So all the numbers less than 4 and equal to 4. So am I going to do an open or closed out at 4? Close, because it's equal to 4 also. And then which direction is it going to go? Where are the less than numbers? Left, yep. Good? So do the got it's now. So go to the next page and those next two. Good? All right, so on this one, we have a -5. How do we turn -5 to 0? Yeah, +5. So n is less than 2. Okay, and then is that going to be an open dot or a closed dot? Is it equal to or not equal to? Does it have the line? No, so it can only be less than 2, so we're not going to be able to fill in at 2. Only to the left.
So how do I know if it's
So if it can only be less than 2, then it's going to be an open dot at 2 because it can't actually be 2. If that was less than or equal to 2, then it can be 2, so you colored it.
Oh.
Okay? Are you done? If you're done, just go to my desk. Okay?
Oh, okay.
All right. And on here, how do I make a +8 into 0? -8. So we get m is greater than or equal to 10 minus 8 is 2. Okay, so now this says m is greater than or equal to 2. So now since it could be equal to 2, you're going to color it in there and then go to the greater than. Okay? Any questions on that? Okay, so now we're going to go back through and do the same thing but with multiplication and division, okay? So, for these ones, you're not trying to make like an x plus 0, x minus 0. You're basically trying to make a 1x because 1x is the same as x, right? Sorry. So here, we have 4x. 4 divided by what is 1? 4 divided by 4 is 1, right? So if we do divide by 4, that's going to make a 1x. Do it on that side too. 6.4 divided by 4, 1.6, I think. Is that right? Yeah. So then that's just going to be your single dot at wherever around 1.6 would be. Okay, for B, this one already has a divide by 4. So what divided by 4 is 1? 4. So if I do times 4 on the top right here, then that's going to give me that 1x that I'm looking for. So multiply here. That's going to be 1. X equals negative 1 times 4, which is negative 4. And then just have your single dot at negative 4. Good? Go ahead and do the got it if you're done with that one. Done? About? All right, so on this one, negative 2x, we need to make that a 1x. So negative 2 divided by what is 1? Negative 2, right? It has to be divided by exactly itself, otherwise it's going to be negative 1, okay? So negative 2 divided by negative 2, so divide by negative 2 here. So you have x equals negative 4. Done. And this one already has divide by negative 3, so what could I multiply this by? What divided by negative 3 is 1? Negative 3. So now that's going to be 1x, so x equals positive 6. Make sense? Okay, now we're going to move to inequalities. This is where your special rule that we talked about comes up. So it's only multiplication and division, and only inequalities. That, remember how we talked about that if it's 6, and then if you divide by the negative, then it no longer works. So you have to flip the sign if you multiply or divide by a negative. Okay? You have to remember. So this is that section. All right. So right here, we have divided by 8. What divided by 8 is going to be 1? 8, yeah. So 8 divided by 8 is 1, so we'll multiply that. C is greater than or equal to 8 over 4, or how could I rewrite that? C is greater than or equal to what?
4 over 2. No.
Yep, so
Yeah.
just 8 divided by 4 is just 2. So then, am I going to have an open or closed audit too? Closed, because it can be equal to, right? And then going to the right or to the left? Greater than?
Right.
You have to think about like all the numbers that are bigger than 2. Where are they? This way or this way, okay? And then you can get improving it. And then this one, negative 3 divided by what is 1?
Negative 3.
Negative 3. This is where you have to flip it because it's not going to work, okay? So it's used to be less than. We're going to change it to greater than.
Wait, why?
Because I'll show you on this. If you don't, so if you know something that for sure works, so negative 7 for sure works in this, if you plug it in now without flipping it, it doesn't work anymore.
Okay.
So in order for all the solutions to still be solutions, you have to always flip it when you multiply divide by negative.
Okay.
So then open dot at negative 4, going to the right now. So always look at the new one. Okay, and then you guys do the two got it ones. Thank you. Yeah, and then just text me, let me know like
Okay, yeah.
you guys say.
Alright, thank you.
And I think I would drink water.
All right, let's go over this last one, guys. All right. So for this one, so what 5 divided by what is going to be that 1?
5.
By 5, right? So you're going to have G is less than 5. So is that open dot or closed dot?
Open.
And then going what direction?
Left.
Left. Yeah. Okay, and then on this next one, what divided by -2 is 1?
-2.
Yeah, -2. So since I divide or multiplying by a negative, what do I have to do?
Switch it.
Switch it. Yeah, so that's going to now become a less than or equal to. So it's only when you multiply or divide by a negative number. That's the only time you have to worry about it. Okay? So now you should have a closed dot at -4 going to the left. Any questions? Okay. So the last thing that we're going to go over is how to check your solutions. So here, if you want to check an answer, you're basically going to plug your answer in for the variable and just simplify it all down. Once you're there, if what you get is true, then it is a solution. If what you get is false, then it's not a solution. Okay? It's not necessarily if it's the same on both sides. That's not how it's going to be. Okay? Keep in mind, too, on a quiz or something, if you're going back and you're plugging in all your answers to check them, that'll work for the equal sign ones. It's not going to work for the inequalities, okay? Because, for example, if I get, or if the actual answer is, let's say, x is greater than 1. So if I pick a number that's greater than 1, give me a number that's greater than 1.
2.
A bigger one.
2.
Bigger one.
Oh, wait, I already said
38, sure, yeah. So you plug in 38, because 38 should work, right? It's bigger than 1. You plug it in and it works. But that doesn't necessarily mean that x is greater than 1. Like if I get total wrong answer and I get x is greater than 15, 38 is still bigger than 15. Does that make sense? So it's still going to look like it's the right answer when it's not, just because something that they have in common checks. So the equal sign ones, yes, you can check them. Inequalities are a little trickier. But we're just going to practice checking a few solutions. Let's see. All right. So on this first set, you have x plus 5 equals 11, and you want to check 6 to see if 6 is a solution. So put that in for x. 6 plus 5 equals 11. What's 6 plus 5? So you are not trying to figure out if that's equal or not. You're trying to say, is that true? Does 11 equal 11? Yes, that is true. So that means that it is a solution.
Can we just like put true, or do we have to put solution?
Solution, not solution. Yeah. So if you're gonna put one or the other, so then if you're gonna leave one off, leave the true off, and you just think that it's true, and then put the solution, not
Okay.
solution. All right. On this one, we're checking 12. So 4 times 12. What's 4 times 12?
48. Okay.
Okay. Is 48 bigger than 48?
No.
No. So this is not a solution. And then do the next two.
Can we just do like initials and AS?
Yeah. That's fine. All right, let's go with the got it. So you're checking 17. So 17 minus 7 is less than or equal to 8. What's 17 minus 7?
10.
10 is less than or equal to 8. Is that true or false?
False.
This is not a solution. All right, and then this one checking 2. 2 over 5. What's 2 divided by 5?
Not 10.
Yeah, not 10. 0.4 equals 10 is not true. So that's not a solution. All right, good. Okay. So let's do the lesson check now. Mhm.
Is the IXL starting today?
I think so, yeah.
Right there. So the first one would be
On there.
IXL.
Yes, you should log in right now.
Wait, how much did it?
It's online. Yep. All right, guys. Answers are going up.